Hello everyone. So let's start with another question in the two pointers. So this is a very famous question: stock buy and sell. Let's go through quickly through this question. So you're given an integer like array prices I, and which is having the price of a given stock at any ith day. Now what you want to do is like you want to maximize a profit by choosing like any single day to buy one stock and choosing the different day in the future to sell that stock. So you to in case like you want to make profit on any like price in any case, it's definitely like you want to buy today and you want to sell it any day, which is day after like after like buying something, and you need to sell that at a higher price. Like if you're buying on, suppose, on the first day, then if you're selling on this day, you're having a loss, right? So we need to make profit, but we need to do in such a way that it is on the like you're having the maximum profit, right? Now, if you're having like all the days already with you, right? Like all the prices, seven, all these are all the prices. Now you need to choose a one day and another day in such a way that you're making the maximum profit. So I think if you just go through this array, what we can find is like if you choose one and then if you choose six, I can say, yeah, this is making the maximum profit. So let's think about it in case of like in like in the case what like how we can solve this question actually. What algorithm can we apply here? So since this is an array and we are always traversing in like in an array in one direction, we are like either we are starting from the end or either we are starting from the first value. So what we can say is like we can think of whenever we are working with the array, we are only having the information of uh, the value which is processed or like on which pointer we are currently on. So like initially we will say suppose we know let's try start from the index 0, so we know okay this value is 7. Then what we like we can traverse in the right direction, then we know the value is 1, then we know the value is 5. So why I'm saying this is because of this condition or like because of this nature of array, we cannot predict like suppose if we are on the first index, we cannot predict or we cannot have or we don't have that information that which value is the like highest from the last array. To have that, either we can like write one algorithm in which we can take this array, the remaining integers, and then we can try to find the maximum out of it. What if we do this? What will happen? If we need to find the maximum out of this, we need to traverse through each element and then like come to a result that okay, this is the maximum element. So if we do like this, so for each element we can say we need to traverse again the whole array. So it will be n multiplied by n, so which will be n square. So definitely n square is not a great time complexity and we cannot do this. We need to optimize this. So we need to think of some better approach than this. Okay. Since we only can have like the information about either the stocks or like either the prices which we have already processed, we have gone through, or the price which we are like currently on. So we can say 7, then 1, 5. Suppose we are at the second index. So we know the value is 5 and we might have processed through 7 like we are definitely processed through 7 and then 1. So can we store some information about this? Yes, definitely. So what we can say is let's keep storing the information like till now we have got like which is the maximum we have got till now and which value is the minimum we have got till now. So if we store that information, what we can say is in case like suppose we say 7. So we can say okay, we don't know like this is the first value. So let's say this is our the maximum we are buying on this day, right? So let's say this is the maximum. Then if we say 1, can we say this is the maximum? No, this is less than this. So we can say no, this is not the maximum, but this is the minimum, right? And we need to buy on a day which is the minimum. Okay, so let's update that. Okay, now the minimum is updated to 1 and maximum. So maximum, we can say this is not the maximum one. So let's say we also have a profit, like the maximum profit till now what we have made. So can we like sell it? So we cannot sell it, right? This is the maximum one. So what if I'm selling it today, then like on the same day, then I can make the maximum profit as one, right? So if we have gone through the first one, the max profit, max of the profit is still what? 7, because we could have like buy it on this day and then sell it on the same day, right? But in the question it is saying that we need to choose a different day in the future to sell that stock. So if we are doing this, so that means we cannot sell it, right? So still the profit we cannot make it, because we're not having any maximum value. So as soon as like we find something as a like we need to find something which is greater than this minimum value, then only we can say we can update the maximum profit. Let's move ahead. We have 5. Now let's process this. 5. This is greater than the minimum value, right? So if this is greater than, we can say yes, we can make some profit. What's the profit? Profit is 4. So that is definitely greater than 0. So we'll update this. The max profit till now we can make is 4. The next value is 3. Let's process this. Is this the minimum value? No, I think it's still not the minimum value, right? We already are having like we are already having one minimum value as 1. So can we make a profit? Yes, we can make some profit. But is this the highest profit? No. It's still, if we have sold on this day, we have already made the maximum profit. So yeah, uh, we can move ahead. We will not update this max profit. Then we'll say 6. Yes, this is greater than, and this is not the minimum value, of course. So still our minimum is still, we are good with the minimum value. But can we make some profit? Yes, we can make some profit. Okay, but also this profit is greater than what we have made till now. So we will say, okay, we can still make some more profit, which so we'll just update the max profit with 5. Then let's move ahead. 4. Let's process this. No, this is not the minimum value. We can still like this is we are good. Still we are good with this minimum value. It's still smaller than 4. Can we make some profit? Yes, but it's still not greater than the max profit. So we will just leave it. Now after this we can say, yeah, max profit we have calculated as 5. So we are done with this, right? And in case we cannot achieve any profit, we need to return 0. So let's assume a condition in which we cannot make any profit. So it can only be the condition when it is in the descending order, like right, 7, 5, 6, 4, 3. In this case, if you buy it at any day, right, on 5th day, on 6th day, or 4th day, or this at any day, right, or like this is sorry, not the days, like it, at this price, at this price, or at this price, you cannot make any profit, right, or sell on selling any day in the future. So we can say max profit if we initialize with 0, and we can keep on checking. We every day we find a minimum value, right? 7, if we say this is the minimum, right? Then 5 we can say okay, then the 5 will become the minimum. As soon as the 5 like anything becomes the minimum, we'll say okay, there's no need to like check for the profit. Then likewise we just go forward, and maximum profit will always be 0. Fine, so let's try to write the uh, pseudocode for this. So we can initialize one pointer, or let's initialize one um, value. Let's call this as min value, and let's initialize this with 0. Then let's initialize one more value, which we call as max underscore profit. Let's initialize with also, this one is also with 0. So this minimum is nothing but we need to store like at which position the minimum value we have. So let's call this as min I, which is nothing but the index, which is like we are storing the index of the minimum value. Okay. Then now let's start traversing the array. So we can have a for loop in which we can have an I integer which will go from 0 to n minus 1. Okay, at each point of time or like at each day, what we need to do is if the prices at I is less than the price of the min I, that means we have found a new minimum value, right? So we will just update the index that okay, this is the minimum. Now since this is the minimum we are updating, we can say we still need to sell it, right? Because we need to sell it when the price is greater. So this is done. Then in the else condition, what we can say is in the else condition, it means like this is a price which is greater than the minimum value we already have. So that means yes, we can make some profit. How much profit can we make? We can make prices at whatever the current price we are at minus prices of min I, right? This is the profit we can make. So we need to find out like, is this the maximum profit? How we can check it? We can say the max profit is equals to, so we will update this max profit if it is maximum, right? So we what we can do is in every programming language there is some like we can do initial like use any native function of like calculating the max between this and the max profit, and once this for loop is done, at the end we just need to return max profit, and that's it. This is done. What will be the time complexity? The time complexity will be big of n, since we need to like the worst time complexity, and since we need to go through each of the index, like each of the uh, value to know the information and process the information. And then what is the space complexity? That will be big of 1 because we are not creating any new array. We are just creating a few pointers, and like this is and as good as time complexity, like a constant time complexity. Yeah, thank you.